Good afternoon, everyone. Hope all is well. Hope everyone's doing all right. So last time we talked, we discussed 7.1. Today we'll get into 7.2. 7.2 is permutation combinations. So we're gonna look at permutations first. So permutation is an ordered arrangement of items that occurs when no item is used more than once and the order matters. Once again, permutations it's an arrangement, an ordered arrangement of items that occurs when no item is used more than once and the order matters. Scrolling up. So we have 6 comedians that we're looking to arrange in a lineup. They're going to perform. We have Kevin Hart, Dave Chappelle, Chris Rock, Tiffany Haddish, Will Ferrell, and Trevor Noah. All right. So we want to know how many different ways can you arrange the lineup comedians to perform? All right, scrolling up on comedians. So the way I normally do a problem like this is I'll set up boxes that represents each performance slot for the comedians. So we have 6 comedians, so I have 6 boxes. And what I put inside of those boxes is how many options I have for each box. So in the first box, I'm gonna have 6 comedians to choose from. Now, when I get to the second box, I don't want to put 6 there because I don't want the option of whatever comedian went first can also go second and so on. So when I put 6 comedians in that first box, I'm going to choose one of those comedians. And then when I get to the second box, I have 5 comedians left. Then when I get to the third box, 4 comedians, 3, 2, and 1. All right, so that's how that works for us. And that ensures that if someone went first, they're not an option to go second, third, fourth, fifth, or sixth. Now, once I have my options laid out in each one of my boxes, I can multiply those together based on last section where we talked about the fundamental counting principle. So 6 times 4 times 3 times 2 times 1. I think I left out 5. 6 times 5 times 4 times 3 times 2 times 1. That'll be 720 different ways that we can arrange these comedians. All right, so everybody okay with that? By holding on to the dark blue. All right. All right, next question. In how many ways can the comedians perform if Kevin Hart goes first and Dave Chappelle goes last? So once again, we set up our boxes for each performance slot. And the same thought process holds true. How many choices do you have for each box? Now, in this case, they give us certain stipulations going into it. They say that Kevin Hart has to go first and Dave Chappelle has to go last. All right. Right, done with the red up top. Trying to give people a chance to write that example before I write. I'll scroll up, I mean. All right, so once again, how many choices do you have for each box? Notice in the first box, we have one choice, that's Kevin Hart. And in the last box, we have one choice, that's Dave Chappelle. Those were the two stipulations that they gave us. Kevin Hart goes first, Dave Chappelle goes last. So we only have one choice in each case. Now in the middle, our middle four boxes, it doesn't matter which comedian goes first, goes next. But keep in mind, two of the comedians have been taken up because Kevin Hart's first, Dave Chappelle's last. And these are the four comedians left. And then we can do our generic countdown in the middle of 4, 3, 2, 1, because we don't want them to be repeated either. And then from there, we'll multiply those numbers together. And that'll give us 24 different ways that we can arrange the comedians to perform if Kevin Hart goes first and Dave Chappelle goes last. All right, questions so far? Let's see, writing. All right. Hold on the green. All right, let's look at factorial notation. In mathematics, if you see the exclamation point, that represents factorial notation. And that just means you would count down from that number by ones all the way down to one, and then you multiply those numbers together. So an example of that is 4 factorial. You have 4 times 3 times 2 times 1, which will give us 24. So you count down from that number by ones all the way down to 1 and multiply all those numbers together. So if I had 100 factorial, that would be 100 times 99 times 98 times 97 times 96 all the way down to 1. And you multiply those numbers together. 1 factorial is equal to 1, and 0 factorial is also equal to 1. All right. So let's look at how we would evaluate with these factorials. So we're going to look at the long way first, and then we'll look at a shorter way. Exploring the long way makes us help us with understanding and further appreciate doing it the shorter way. So we have 8 factorial over 5 factorial. The long way is to list out all of our numbers in order to be able to cancel out. So here, if I have 8 factorial, that's 8, 7, 6, 5, 4, 3, 2, 1. And then down on the bottom, I have 5 factorial, which is 5, 4, 3, 2, 1. So now when we deal with fractions and multiplication and the way we have it set up, the 5, 4, 3, 2, 1 can cancel because it's in common with the top and bottom. That leaves us with 8 times 7 times 6, which is 336. So once again, this is considered the long way because if we had 100, we don't want to have to write down 100, 99, 98, 97, 96, 95, all the way down to 1. So the shorter way is to look at what I did in the purple. We recognize at first when we listed it all out that within the 8 factorial is 5 factorial. See 5, 4, 3, 2, 1. So what we can do is just count down to the 5 factorial. That's what I have in common with the top and bottom. That's 5, 4, 3, 2, 1. And then we would just cancel that out, and that'll leave us with the 876. And then multiply those numbers together, that'll be 336. All right. Doing a couple more just to make sure we're okay with the concept. And this factorial button or option should exist on your scientific calculator if you have a scientific calculator. If you can't find it, always feel free to bring it to class, and I can make sure that you're okay with using your calculator. There are also, scientific calculators online, so I'm not asking you to go out and buy anything, but you should have something that can calculate it for you, something reliable that can calculate it for you as you go throughout, these sections. So 100 factorial over 98 factorial. Notice all we do is count down to 98, and then 98 factorial, 98 all the way down to 1 will cancel out with the top and bottom, leaving you with just 100 times 99, and that'll be 9,900. And then 26 factorial over 21 factorial. I would just count down to 26 to 21. The 21's factorials will cancel, leave me with 26, 25, 24, 23, and 22. Multiply those together. That'll be 7,893,600. You'll see writing. All right. So let's look at the formula for permutations. Everybody holding on to the light blue. So a permutation of n things taken all the time. N is always going to be a larger number. And what we mean by this is that let's say if I have a class of 30 and I wanted to know how many different ways could I choose 5 people to go on, let's say, a field trip out of this class of 30. So it's a permutation of 30 people taking 5 at a time. So your larger number is always going to be n. So we have NPR, that's n factorial over n minus r factorial. Everybody holding on to the orange. Everybody okay with black? All right, so we have you and 19 friends have decided to form a consulting firm. The group needs 3 offices. You got CEO, operating manager, and the treasurer. And how many ways can those offices be filled? All right, so when dealing with these type of problems, you want to figure out what is N and what is R. Remember, N is always going to be a larger number. R is what you're pulling out, that larger number. So when we look at this problem, it says you and 19 friends. A lot of times when you see this problem, when people see this problem, they get caught up on the 19, but it's you and 19 friends. So that means 20 altogether. And we want to know how many different ways can we pull 3 out of the 20. So N is 20, R is 3. And I'm gonna walk us through the formula and how to calculate it, by hand. Just make sure we have an understanding of how it's calculated. But if you have a calculator that can do it for you, then that's fine as well. Just make sure you have something reliable as you go throughout your homework and through your tests, and ultimately in your final exam, so that you can calculate permutations and combinations. So that's 20 factorial over 20 minus 3 factorial. 20 minus 3 cancels, not cancels. 20 minus 3 is what we do first, and that's 20 over 17. 20 factorial over 17 factorial. Take the 20 down to 17 factorial so that it can cancel, leaving us with 20 times 19 times 18, and that's 6,840. All right, let's scroll up on the blue. All right, next one. All right, good. All right, so you're working for a TV network. Your assignment is to set the schedule for Monday evenings between 7 and 10 p.m. You need to schedule a show in each of the 30-minute time blocks. You can select from among 13 comedies how many different schedules can be arranged. All right, let's scroll up. So we have 13 comedies to choose from, 6 time slots to put them in. So that means N is 13, R is 6. Plug them in the formula accordingly. 13p6, 13 factorial, 13 minus 6. Ultimately, give me 13 factorial, 7 factorial, and 1,235,520 will be our result. All right, let's look at one more dealing with permutations. Everybody holding on to that. All right, permutation of duplicate items. So we have n factorial over p factorial times q factorial times r factorial and so on. We can continue that on as many as we need. So n represents the total number of items. And then p is the number of p items that are identical. Then we have q items are identical and then r items are identical. All right. And how many distinct ways can the letters of the word Mississippi be arranged? All right, so first we will count the letters of Mississippi. There are 11 letters, so that's the total number of letters that we have. So that's why N is 11. Then we say that I is repeated 4 times, S is repeated 4 times, and P is repeated twice. So that's how we have the formula set up. My total numbers on top, that's N factorial or 11 factorial. Then we have 4 factorial times 4 factorial times 2 factorial down bottom. So when you go to throw it in a calculator, you probably want to use parentheses to make sure that whatever's in the bottom stay in the bottom. And then ultimately you'll get 34,650. All right. Everybody good on this page before we go to the next one. We're going to do combinations, which is in the same section, but I just have it on another page, note page. Everybody good? All right, let's look at combinations. Like I said, it's still in 7.2. This time we're looking at combinations, very similar. We talk about combinations in comparison to permutations, just that with permutations, the main thing is that the order matters. In combination, the order does not matter. So then when we look at the formula for combinations, same thought process, same flow as permutations, just that it has something extra, has this R factorial extra down bottom. But it's the combination of n things taking R at a time. Once again, n is always the larger number. So we have n factorial, n minus R factorial times R factorial. All right, we'll look at a problem that uses combinations. So we have a 3-person committee and it's needed to study the ways of improving public transportation. How many committees can be formed from the 8 people on the board? All right, so we have 8 people in total. We want to know how many different ways can we choose 3 out of the 8. So N is going to be 8, R is going to be 3. Scroll up on dark blue. So that would be 8 factorial over 8 minus 3 factorial times 3 factorial. That's the formula that we have for combinations. So the 8 minus 3 is what we defer to, which turn to 5 factorial. And so we can't combine the 5 factorial and 3 factorial. We just have to expand them out or cancel out. So I take the 8 down to 5 and let that cancel out. I try to color code it so you can see what's canceling out with what. So the 5 factorials cancel, leave me with 876. Now there's 3 factorial. If I expand it out, there's 3 times 2 times 1. 3 times 2 is 6. So that cancels out. There's 6 right here. And it leaves me just 8 times 7, which is 56. So it's 56 different ways I can arrange 3 people to be taken out of the 8. Okay. Questions on that one before we look at it? All right. So in poker, a person is dealt 5 cards from a standard 52 card deck. How many different 5-card poker hands are possible? So there's 52 cards altogether. And we know how many different ways can we choose 5 out of the 52. So there's 52 C5. And so if you were to do the formula by hand or throw it in the calculator, it'll ultimately give you 2,598,960. All right. Everybody good on that one? Got one more. We should be okay. All right. In January of 2017, the U.S. Senate consisted of 46 Democrats, 52 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? All right. So when we look at our committee having at least 2, well, not at least, having 2 Democrats and 3 Republicans, those 2 Democrats have to come from the 46 Democrats that's in the party altogether, or in the Senate altogether. So I can't pull those 2 Democrats from anywhere else. So I need to know how many different ways can I choose 2 out of those 46 Democrats. So 46 C2 is 1,035. With the same thought process, I need to handle the Republicans the same way. Those 3 Republicans have to come from the 52 Republicans that's a part of the Senate. And it cannot come from the 46 Democrats or the 2 independents. So that'll be 52C3, which would be 22,100. All right. Any problems with that? Once you have those 2 numbers, once again, we're leaning on the fundamental counting principle from 7.1. We need to multiply those 2 numbers together. So 1,035 times 22,100 will give us 22,873,500 different ways that we can create a committee with 2 Democrats and 3 Republicans. Questions? Any questions? Uh, All right, so my last class, we went a little longer in copying these notes, so there's no rush though, so I'm not gonna go on to the next section. 7.2 is where we stopped, and so it's a good place to stop. 7.3 is where we'll pick up next class, and I'll go from there. All right. Anybody have any questions, feel free to stay back. If not, I will see you next class.